in the waterloop. Waterloop.
You're in the waterloop. This is Travis. I am joined today by Dr. John Burns. He's an assistant professor in the Marine Science Department, University of Hawaii at Hilo. John, aloha.
Hey, thanks for having me.
Yeah, I can, say that with some credibility since I lived in Hawaii too for 5 years. I'm not just doing the tourist thing by saying that. So I'm excited to talk to you today about coral reefs and a lot of different topics about why they're important and their health and the sunscreen ban in Hawaii and so forth. So I wanted to start with that health question. Why are coral reefs so important to the marine ecosystem?
They just fill a really unique role in the world's oceans. I think, one of the most intriguing ways to think about it is if you imagine the small amount of area they take up, right? I mean, we know it's hard to imagine. We can't see the globe at once, right? In all of its, circular or flat glory, depending on which case you're a part of there. But it's huge, okay? It's massive. The ocean is the majority of all of that. So we're familiar with the ocean as just being this vast blue expanse. In this tiny amount of area, you've got these shallow habitats, right? That are restricted. They've got to be in tropical or subtropical areas. They have to be shallow. They need all, they're very finicky. They've got all these characteristics that they like. So they don't take up a lot of space, but at the same time, they're the most productive and diverse ecosystems in the ocean, right? I mean, they rival rainforests in terms of the carbon they fix and the oxygen they produce, but they just don't take up as much surface area. But per unit meter, you're talking about, one of the most productive systems that we've got. So it's really, a wonder of this planet that they happen to develop and grow and thrive the way they do, because with their existence, you've got this unbelievably diverse habitat. And I say diverse in every imaginable form. I mean, the shapes, the colors, the sizes, the structure, and then in each one is like a wonderland, right? I mean, all that space is like a bustling city. So you've got habitats for all shapes and sizes of fish, inverts, you name it. And the craziest part about it is we've only scratched the surface of what's out there. We go to the reefs that we can go to. It's hard, and it's hard to see a coral reef. One, you have to breathe underwater or hold your breath as long as you can.
Yeah.
And those locations that it's restricted to, like I was saying, in the tropics, Hawaii, we're very fortunate to have a lot of coastal access, but many islands are just very remote and very difficult to get to. So, they're just this amazing, the common term is like rainforest of the sea, but I mean, I'm a coral reef person, so I like to say rainforest of the coral reefs of the land,
Yeah, I like that. Turn it around on them.
Yeah.
A couple words you said I want to follow up on. You called them like a wonderland. I mean, I know that's how I feel about coral reefs. Like, it's just amazing to be down there, whether you're scuba diving or free diving, snorkeling, whatever, and just taking in those colors and shapes and diversity. It is amazing and beautiful. You call them productive. What does that mean when you say that the coral reefs are so productive for the ocean?
Yeah, that's a really good question. I mean, just to follow up the Wonderland, it's like Dr. Seuss down there,
It is. Yeah.
You don't imagine those shapes, you have to see them to realize that they exist. But on that note, right, the shapes, so you've got, when you have all this multitude of shapes, right, you have a diverse habitat that supports a number of organisms. So the word productive can be applied several ways. Like, one, the corals are very special, unlike many organisms where they are an animal. Most people don't realize that. They're an animal. True and true. But they have algae that lives inside of them, right? In this mutualistic relationship, meaning the algae benefit, they've got a place to live in the coral. And now the coral essentially has solar panels in its tissue that's photosynthesizing all day. I mean, the equivalent is if we had that, we wouldn't eat, right? You just put your hand out the window and you're full. So that enables them to, at the base level of what productivity means, right? It's fixing carbon, producing oxygen. But it's bigger than that, literally, in the sense that the habitat's supporting all this biomass of fish, right? So they're productive in the sense that they are, storehouses of oxygen. They're fixing carbon dioxide, which is important for our planet. And then they're home to more species than we know. Like we literally have no idea how many species they hold because we haven't discovered it. And the food web is pretty simple, right? You got a lot of small fish, they feed big fish, that feeds bigger fish, and pretty soon you get this high level of biomass among those levels of the system, and that produces food.
Yeah.
That's why there are so many people around the world that get their protein from reefs, because it's got all these fish.
Yeah. I saw a statistic, you can tell me if it's accurate or not, that something about reefs cover like 1% or less of the ocean's floor, but support like 25% of marine life.
Yeah.
Okay.
I mean, it's like we have a lot of those statistics, and they're sort of like perfectly general. Because like I said, we don't know. Like I was at a workshop once. We estimated that we've visibly seen maybe 1/700,000th of the actual reefs out there. I mean, and that's probably as crazy a statistic as anything, right?
Yeah.
Back of the envelope. But the moral of the story is, like, yeah, we really don't know. But if you take into an account, what we do know about the depth of the ocean, where they can exist, right? They need sunlight, so you're not going to find them at the poles. They need warm water, so they're restricted to the equator. So yeah, it's probably covering at most a percentage of the planet.
Yeah.
But if you take how much life is in, like, the average reef system, then yeah, it's probably easily supporting 25% of that. Which is crazy. I mean, that when you really step back and think about it, is nuts.
Yeah. So it sounds like 1% of the ocean's floor that they cover is probably a very high estimate. Even they're this small sliver. You mentioned something else about the kind of the carbon and oxygen and all that kind of good stuff going on. What's their role in the health of the environment, the planet, kind of that interplay between the oceans and the atmosphere and so forth?
Yeah, I mean, I love that question. I get it a lot. People ask me, why should someone in the Midwest or New York care about corals? And I like it because it's the easiest question to answer. Like, do you like oxygen? Do you like breathing an environment with enough oxygen? I mean, that's why it's interesting because, it's so simple for us. We grow up with it, understanding like, oh, we need those plants. We need trees. They photosynthesize. They make oxygen. Like, it's a direct connection. I've seen it my whole life. It's no different underwater. I mean, most of our oxygen is produced by the oceans, right? You got tons of phytoplankton. You've got coral reefs. So ocean health is just as important for maintaining our oxygen level and fixing carbon dioxide as is forest health. Like we don't even question it when someone tells us, hey, if we go and pave the whole world, we're screwing ourselves over.
Right.
But if you go and destroy the reefs, you're doing the exact same thing. So I mean, at that basic level, it's super important to maintain a climate that we need to thrive as humans.
Unfortunately, there's some people that think that we can just pave the whole world and it's not going to make a difference, right?
Well, so I mean, if we get a bunch of, there you go.
I always love going in for a hike in the forest, and when it's like you almost can feel it like breathing on you when you're deep in the woods somewhere or whatever. And so it's like the ocean's breathing on us too. Cool.
Yeah.
What about the other benefits of coral reefs other than kind of that for the marine ecosystem and for the oxygen and so forth? The importance of reefs for like the coastal communities that they're by, economically and all that.
I mean, that's where you get really what I like to call, just direct benefits, right? I mean, direct as in spatially, the reef is there, I get a benefit here. So like we were talking about with productivity, they're an enormous food source for coastal communities that live next to reefs. In Hawaii, they've got such a deep cultural connection to coral reefs. And the reason is that it is the base of the food web, right? And they consider the coral polyp the very initial organism in the Kumulipo genealogical chant, right? So first came the coral polyp and then everything else. And if you think about life in the islands, that reef is your basis of your food supply. If you're living on the coast, that's your refrigerator. I mean, that's your food. And then it's bigger than that, where they break up an immense amount of wave energy. So if tomorrow we went and just removed all the reefs, the East Coast where it's tropical, right? The Florida reef tracts, et cetera, Hawaii, every place with coral reefs would now just be exposed to unrelenting wave energy. And you would have hundreds and hundreds of millions of dollars all over the place of coastal damage and erosion because that reef is no longer buffering that energy that's traveling all the way across, global oceans and landing on your coastline.
Yeah.
So we often forget that value. And then, of course, yeah, there's natural products, right? There's all types of chemicals and compounds and molecules we discover on corals. And that's one of the saddest things to me, is that I'm just sort of scared that, we will lose them before we've had the opportunity to discover, what's out there that can benefit us in our day-to-day lives.
That's something you hear about rainforests too, is all the kind of medicines and things that have come out of those rainforests. So I really wasn't familiar with that with coral reefs, that there's been, that type of value from there. Is there anything you can kind of give an example of?
I mean, sponges is one that comes to the top of my mind, right? Like a healthy reef has a lot of diversity in all types of animals and organisms, all shapes and forms. And I mean, sponges are one that are often acquired in that area of research, like natural products, and they found a lot of medicinal compounds come from that. And we are in an existence where our ability to understand and learn from the world is coupled with, our technological advancements. And so it's a catch-22, because as we get more advanced, we're putting environments at a greater risk.
Yeah.
We also have more tools to go out there and find and extract these things that could cure cancer.
Yeah. I guess another benefit, is also kind of the tourism, that goes around these for those communities that have access, right? Like it's a nice engine.
Yeah, I mean, in Hawaii alone, the last estimate I saw was like $364 point something million a year. They generate through economic revenue, be it fishing, tourism, et cetera. And that's like $1 million a day. The global estimate is 40 something billion dollars that they're worth. So yeah, I mean, you just go to any harbor in a tropical place with tourism and you see dive charter boats going out every day. You see fishing charter boats that, even if they're going offshore, the inshore reefs are nursery habitats for fish to grow and develop and then go back offshore. So there's everything in the world, especially the ocean, is connected. And so, yeah, like we are fools if we don't think that those economic benefits are dependent on the health of the reefs.
Yeah, and one of my favorite benefits personally is, they help those waves break so they're great for creating this surf spots,
Yeah, I mean, that's what really got me into this. As a kid, I just wanted to be a pro surfer, was obsessed with surfing, and then spent some time in tropical locations and realized that I want to spend time in these environments, and then as I got older, you realize, like, oh, maybe I want to do something to help save them, and then collectively it kind of led to the interest in science and conservation.
Yeah, and then you get to be studying and be around these the reefs and doing all the stuff you love with it. That's awesome. Yeah. So this is all pretty positive about how awesome reefs are. I guess we have to shift gears a little bit and talk about kind of their health and what's going on. And I'm definitely curious about kind of the global health of coral reefs, just what that picture looks like. Obviously, there's a lot of variability from place to place. It can be a localized issue, and we can dig into that. But there's all these stories out there about coral reefs and the bleaching and impacts of global warming and so forth. So what's your assessment?
It's hard to give a one size fits all answer, because it's different everywhere around the globe. At the simplest level, we're seeing declines in coral health associated with our activities on this planet and the impacts that we have on our surrounding environments. I studied, and I still do, a lot of my research is very specific on coral health and disease. So I do a lot of 3D mapping now, but that is all built out of that desire to understand what makes corals healthy, right? And then what happens when they become unhealthy and die. Like, how does that scale up through the ecosystem? How does it affect the fish? How does it affect the resources we as humans depend on? It's different, right? I mean, you've seen, like in Florida, for instance, on the East Coast, they had really horrific disease outbreaks that just wiped out entire coastal tracts of reefs. It's nothing like it used to be. And with that has been a large reduction in those resources we were talking about. Places like Hawaii, have done better. They haven't had as many detrimental large-scale disease outbreaks, But at the same time, we have not been immune to stress and problems with coral health. We've had elevated seawater temperatures for back-to-back years, which has never, it's an unprecedented occurrence. I never thought I would see mass bleaching in Hawaii. I mean, I hoped I wouldn't really in my lifetime. And I've got sites in the northwestern Hawaiian Islands that are completely dead. You know,
and what's the bleaching about? What causes the bleaching?
Yeah, so it's a really good question. And one thing, when you talk about coral health, you got to understand, like I was saying, they're animals, right? But they're animals that live in this consortium with all these other small organisms. So they've got algae, they've got bacteria they depend on. So one difficulty with studying coral health is it is so hard to figure out what made them sick in the first place and what dictates why they recover. You know, it's not as easy as like doing a medical study where you can look at every patient and be like, okay, well, what was your diet? You know, what, do you exercise? Do you have family history? You know, they don't speak. And a lot of that is yeah. And I mean, a lot of it is clouded by, you know, say I take a tissue sample, it's very hard just to tell, am I now analyzing just the coral tissue, or do I have that algal tissue embedded in, and how many microbes snuck into my sample for that analysis? So it's really hard to disentangle what makes them tick. So bleaching, even bleaching, can be caused by more factors than you would believe, right?
Okay.
But the primary one is temperature. And what happens is the water gets too hot, and corals, they kind of exist right at their upper threshold of temperature. Like they like it hot. They want it as hot as they can get it. A little too hot, they don't like it.
Boom.
And what happens is there's some internal reactions that occur, and they'll basically expel that algae, right? That acts like the solar panel in their tissue. Once that's expelled, that algae is algae, right? So it gives it like a green, brown, or colorful pigment that you see. So algae goes, pigment goes, coral looks stark white. Hence, it looks like it's been bleached.
Yeah.
And what's interesting there's a common misconception that when they're bleached, they're dead.
That's what I thought.
Yeah, they're not dead. If they were dead, they would look brown and green, because it takes almost no time at all for algae to start settling all over dead coral tissue, right? Like once that coral tissue is dead and it's just skeleton, boom, that stuff is fouled up like a fish tank that you neglect for a week, right? It takes no time for that thing to get dirty. So when they're bleached, they're actually alive.
That's good.
Yeah, which is good, and they can recover. The problem is they've lost that algae, so they've lost an immense energy source, right? So it's very similar to when we're sick, we turn pale, right? Our energy resources are low, and it's very hard to recover from, say, a bad flu or bad illness when your doctor tells you, okay, you're only allowed to eat a little bit of food now. That's it. Right. Yes. So now at this bleach state, they're also the most vulnerable they can be to all these other diseases. So it's positive a little bit in the sense that we should do everything we can to help them recover from that bleach state. So we shouldn't be diving and having tourism on those reefs. We shouldn't be putting pollution on those reefs. We should do everything we can. They can recover. But it's scary because as time progresses, we tend to see an amplification of these stressors, right? Global temperatures are rising, pollution is going up. And so with time, they're kind of becoming more and more vulnerable to these bleaching events. And that, I think, is why we're seeing a lot more mortality associated with bleaching than in the past. But it is a natural thing too. You got to remember that, right? There's been temperature anomalies in the past. Corals are animals die. So you do get a natural flux of life and death. But you know something's out of whack when you get massive populations that just die, you know, within a couple of months.
Yeah. So the main threat to coral reefs right now is the bleaching from the ocean temperatures being so hot. But you'd probably also say there's other disease issues that are from pollution and so forth.
Yeah, I never like to say there's one thing because it's never that simple. So I think what is most important to remember is that these global stressors are there, they're persistent, and they're getting worse, right? So we need that in our consciousness. We need to think, how do we reduce CO2? How do we change global temperature? How do we battle that? Now, I'm also aware that if you get too focused on the big picture stuff, it starts to become defeating, you know? I mean, like, how can I, in my desk, in this office, get China and the US to agree on a climate deal, right? It's not going to happen. Maybe Trump, the deal master, will work that out, but I don't know if Reefs are his focus. But like I was saying, under that stress, all those direct local stressors are now more important than ever. So I can make a difference every day by just eliminating the pollutants that I'm releasing into a reef environment, by doing everything we can to keep water quality high along the coastline. Don't develop on the coast. Don't have cesspools in your house or septic. Don't let sediments run off, right? I mean, in Hawaii, for example, it can become an abstract thing. Corals in the land are connected. They're near shore systems. So if we don't manage our forests, like here's an example here. We have all these ungulates, right? Pigs, goats, sheep. You lived here, you're aware of it. They're invasive. They don't belong here.
Right.
So if they take over a landscape, they eat all the vegetation. Now the vegetation doesn't hold the sediment. Now when it rains, these sediments flush down the river, smother the reef, and bring all these different, microbes and bacteria that can be potential pathogens. So it quickly becomes evident that you've got all these different factors that, if left unattended, is going to be very harmful for corals. But we can do something today, because all of those local stressors, I can go out and I can do something positive to reduce that. I mean, at the simplest level, I can go shoot a goat and eat it. Right? But that's less ungulate on the hillside. So I mean, there's something I can do.
Yeah. So yeah, it's that old bumper sticker, right? Like, think globally, act locally, right?
Absolutely. Yeah.
That approach. I didn't have this on my list of questions, but is the plastic issue in the ocean impacting corals at all, or even the super microplastics? Is there anything going on that front, other than it being probably, trash sitting on reefs and so forth?
Yeah, I mean, it affects them on several levels. I mean, the most basic level would be that large trash, large marine debris like net, line, large physical objects, that smothers corals and abrades them, meaning that like it'll rip their tissue. And because they're animals just like us, if you get a cut and then you don't clean it, right, you get an infection. And so marine debris can cause disease and infection on corals because it affects their tissue interface, it affects their light availability. So it can like physically have a negative impact. And there's research colleagues that I know have done, here and in Australia, showing that, like, and just areas where there's more tourism and more pollution, they see more increased levels of coral disease. And then what is scary to me is the microplastics, because I think, they're micro, so they get into everything. And studies have shown, you can find microplastics in coral tissue. And I think every organism on this planet is going to see some harmful effects of microplastics in the years to come.
Yeah. Wanted to ask just about those reefs there on the Big Island, especially, I lived over on the west side in Kona, and I would go diving a lot in Puako area. And I lived down south a little bit too, near past Honau now and Ho'okena and, all that kind of stuff. So how are the reefs there, especially on the west side of the Big Island?
I mean, overall, they're doing really well, right? And that's part of what I love here. Like the reefs on this island are just unbelievable. Some of those ones around the South Island, like we've got some projects with some of the smaller fishing communities down there, and we go and do surveys with them. And, there was some pretty devastating mortality from the bleaching events that happened here. So a lot of like the larger mounding corals, and the cauliflower kind of like cauliflower looking branching corals, you never know why, but some certain species or shape sizes tend to be more vulnerable to the bleaching. So we did see a lot of mortality, but, at most of those sites, we're also seeing a lot of recovery, and they are still coral dominated reefs, so it's easy to get caught up in discussions like this and just get negative, pessimistic. But it's also important to remember, like, these are systems that have evolved for really long times. They have the capacity to survive, recover, natural disturbances, hurricanes, that's a part of life for them, right? Yeah. So they can take a beating and they can recover. We've just got to figure out, where do we insert our day-to-day lives so that we allow them to have that capacity?
Sure. All right, well, that's a good segue. I wanted to talk to you about Hawaii being the first place in the world that put a sunscreen ban in place. Not exactly a ban on sunscreen, but a ban on sunscreens that have a couple particular chemicals that are known to be harmful to coral reefs. So we've got the oxybenzone, and how do you say the other one for me, John? Help me out.
Oh, I mean, there's
octinoxate.
Yeah. I mean, there's several. I mean,
okay.
Oxybenzone is a big one. the my thing with the sunscreens is it's a good step in a good direction in the sense that there's these are harmful. I mean, the chemicals they're not good for you. You know what I mean? You put them on your skin, they have a harmful impact. So as an honest, objective scientist, it's not really easy to give you a direct link of if you wear X amount of sunscreen, it's going to have in turn this impact on corals, right?
Gotcha.
In the actual ocean, you've got factors that are difficult to control, like dilution in the ocean, currents movement, water movement, wave action, etc. But in controlled lab experiments, you do see negative impacts on the physiology of these organisms. And so to me, considering that, yeah, it's a harmful chemical to any biological organism, let's look for an alternative, right? So I was supportive in the sense that, I mean, I think there's a lot of other issues that I would love to see get similar attention.
Sure.
And legislation. So it's important to remind people it's not a one-stop shop, right? It's not like we fixed the problem, but it's good to show that with the right education and attention, we can do something to eliminate a product that's carrying harmful chemicals. And it doesn't stop there. I mean, you look at beauty products, all type of stuff that goes in our skin. I mean, read the label of any. I challenge someone to pronounce 50% of the ingredients, right?
Oh yeah, totally.
Yeah, and that's like a byproduct of our industrial revolution. We've sort of had this mindset of like produce first and then see later if it has an impact, instead of make sure it doesn't have an impact before we're using it.
Yeah.
So it's really good to have people out there that are doing quality control and checking these chemicals and saying, hey, if we can limit something, why not do that?
Sure. And yeah, all these chemicals going in the ocean then are gonna, have some type of impact. And it seems like it's good for, like you alluded to, the public awareness, right? Like at least all the attention that this sunscreen ban got in the media and will continue to get as it actually goes into place over the next couple years, has people hearing that, coral reefs are experiencing challenges and stressors and diseases and all that. So at least this kind of gets that in front of people, and then has that side benefit of maybe being healthier for a person not to put oxybenzone on their skin and all that. I think I've read that the sunscreens that have zinc oxide and so forth are better for you as a person and are safer for reefs, or have not been shown to really impact coral in experiments and stuff.
Yeah, I mean, it's a very different thing, right? So one's a metal, it's kind of based around a heavy metal. The other is a chemical compound. I'm always, as a scientist, you got to be skeptical, So I mean,
Sure.
Are they safer alternatives? Absolutely. Doesn't mean that they're the perfect solution. I don't know, time will tell. Metals can interfere with organismal development, so there are possible setbacks, but that's a lot of life, right? You've got to pick somewhere in the gray area that lines up as best you can. So, like one thing people always ask me, like, well, what sunscreen should I get? I tell them like, well, it's not as simple as that, right? It's control as best you can. So yeah, if you need a sunscreen, definitely go with one that doesn't have those chemicals, because it's better for you, and at least as we know now, it's better for the reef. But think about how much you need to be in the sun. Do you want to lay out do you need to be out there 4 hours and reapplying? Like, it's also good to just cover up when you can, stay in the shade. Because and you do want some sun in your day-to-day life that isn't restricted, by blocking. They've got research coming out now showing that, the benefits of vitamin D can actually be activated, through enzymes that are affected by direct sunlight. So you actually need some direct sunlight to get that health benefit, so it's just really not being too extreme with anything, and finding a middle ground that works for you, that you're not exposing yourself to crazy sun and skin cancer, but you're also limiting harmful chemicals to yourself and the environment.
Yeah, I mean, as I've spent more time in the sun at beaches and surfing and stuff, I've gone with more of the long sleeve rash guards and kept on the big hat and everything, and let those things block. You get enough sun anyway.
I know, it's so funny when you're younger. I was the same way, it's just like, whatever, you go out all the time and you look at people, it's like, why are they so scared of the sun? And now I'm that guy, like I got my jacket on, I'm not trying to hide from it, because, there's no shortage of the sun. It comes back every day,
Yeah, no, it's very true. Yeah. wanted to kind of shift to the last section of questions here and just a bit more about your work. I think you've mentioned studying kind of drivers of disease. You mentioned real quickly this three-dimensional work there that I thought was interesting, and I saw that about you. So what's going on there with kind of the areas that you specialize in for research?
Yeah, thanks for asking. I mean, it kind of started all from that same coral health central focus, and seeing these changes happening on reefs from disease impacts, from coral bleaching like we spoke about, and from storm damage, et cetera, right? You see this impact, and I found that there was a limitation with our current technology and tools where we went out and we kind of did what I'll just call now like snapshot science, right? Like we're just taking single images or observations, and I'm saying, okay, at this one point in time, this one spot looked like this. I'm going to look at 50 spots or 500 spots, and you're kind of doing this like general assessment, right, as best you can. But it doesn't afford you like a high resolution baseline that you can really track well over time, right? Even if I come back to the same spot, take the same two-dimensional picture, I'm missing a lot of what's really going on there, right? Like you could have a coral head, but maybe the habitat that coral head provides to fish is because it's got like a hole underneath it, right? Or some branches. And so I started thinking just really basically, well, what happens if these things die, right? Like how does it change this entire ecosystem if they die? Because when they die, they're going to erode. So the whole shape of this reef is going to shift. So as I mentioned before, they're in a flux of life and death, right? Some new corals are forming and growing and old corals are dying. And we've got this constant change going on. And the physical thing that they're changing is the actual habitat structure. So it's like the kelp forest on the West Coast. If I took out all the kelp, goodbye to all those fish, right?
Yeah.
And so then I'm stuck with this thought of how the hell do I measure 3D structure when all I've got is an hour on a dive and a camera? Like what can I do? And there's a lot of ways. People have done stuff with stereo cameras, right? But something that the public should be aware of is like as valuable as science is to your day-to-day life, right? I mean, you get into a car, you use a microwave, you put food in your refrigerator. All of this stuff comes from science.
Yeah.
People notoriously don't want to support research, so I've got to fight tooth and nail to get money to do stuff, right?
Yeah.
Even though it's got a direct benefit to everybody's lives, it's really hard. And so
so many, like you mentioned, so many things we have in our lives and that have improved society has come from, the space program or even the military doing research and experimenting with things. And yeah, absolutely.
Yeah. So
support research, people.
Yeah. So you'd think I would just go to, NSF, National Science Foundation, or any agency and say, hey, I got this idea for 3D. Give me a $100,000 stereo camera, right?
Yeah.
But that is borderline impossible. So I started looking into different technologies, and this was right around the time when this new technology, it's photogrammetry. It's mostly from structure from motion photogrammetry. And, one thing about science we love, I swear it's like scientists just love, the more complex the word, the better. It makes you sound smart or something. But all that means is that I can take a single camera, right, which I had before. And now instead of taking like one snapshot picture, I just take repetitive pictures. Boom, 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 boom. And they've got tons of overlap. Okay. Now, it's just like we used to do back in the day. You take your Polaroid, shoot a canyon, and you like stitch the pictures up on your wall. So same thing. But with computing technology advancements, you can now get algorithms to do all that for you. So instead of me spending days, weeks, months aligning, say, 1,000 images perfectly, I can take the color information in the pixels and just tell the computer to do that. Now, it's a lot harder than it sounds, but it works. So boom, we match all these images. Now, because corals don't move, right? It's a solid fixed feature. So you can apply the same phenomena of life that our eyes do, right? Like because we've got two eyes, and our eyes are actually like twitching all the time, you walk through a hallway, right? And you see how the apparent distance between the walls shift. And so you immediately in your brain calculate, it's going to take me about a minute to walk down this hallway. But you don't stop and think about that and go, how the do I know?
Our supercomputers figure that out.
Compute it right away. So people developed a very similar algorithm that said, all right, well, if there's this fixed feature and it looks one way from this angle, and a different way from this angle, I can start to calculate what its
Mm.
three-dimensional structure must be for it to look that way from all these angles.
Yeah.
So now in a nutshell, I go out, I have my permanent plot, I can just swim as big of an area as I want to, right? I can strap my camera to a robot, to a ROV, like a remote operated vehicle, underwater, anything, right? I could tow it from a boat. As long as I get all these overlapping images, I stitch them together, produce a three-dimensional model. Now I have a permanent, absolute, real representation of that habitat. I mean, and it's so, cameras are so high res now, and I mean, I'm really into photography stuff, so it was a good fit. But I mean, I can zoom in and scale these things, and I can see coral polyps. You know, I can get the model down to like millimeter accuracy.
That's awesome.
Yeah.
Wow.
And so what we're doing now is saying, okay, what type of three-dimensional structure does a mounding coral provide? What type of structure does a branching coral provide? Then we're doing this in conjunction with all these other surveys, like fish surveys, invert surveys, you name it. And the goal is to start to see, if we lose this species, like what is that going to do to the food web? How's that going to affect everything we talked about in the beginning of this interview, right? How does that affect all those resources and services? Can we find out at a certain site what is the most important coral to protect? Because it's the most important habitat.
That's phenomenal. And so this has really been a focus of yours and really just been developing and taking shape the past few years, right?
Yeah, I mean, at first, because, you know, with computer technology, like everyone told me I was an idiot. It would never work. It's impossible. And that was when I knew I was onto something, right? You know, anytime people tell you it's not a good idea, you're like, all right, this might be something then. Right. And you know, I would do this, and I bought this really expensive laptop, which is now like a POS computer in comparison to what I could buy for a fraction of the price. And I'd have it in the lab, and I'd put like 2 fans on it. You know, I'd come in it'd take a week to process something. And so everybody's saying like, you're nuts. It's too expensive and it's too time consuming. And I just kept saying, go back in time 5 years. Yeah. Where we're with computers. You go ahead 5 years, and it's going to be a 25-year leap from where we are now. And almost on the dot in 5 years from then, and I'm beyond that point now. I mean, I can process a model on my computer here on my desk in a matter of minutes. I can do several in a day. I've got my students just chugging through these things, and we're integrating it into all of our monitoring programs with like federal agencies, with NOAA up in the monument. And so, you know, it just took time for people to realize, like, once the technology caught up, it's just a better way of doing it, because every time you do a survey now, instead of just a few pictures, you've got a full high resolution 3D model of your site. And then as time goes on, you can see exactly which corals grow, exactly which ones die, exactly which ones are more vulnerable to disease.
Yeah, very cool.
And we've even tracked how diseases are now spreading in the 3D landscape. So you can see, like, are they clustering in certain areas? Are they moving in certain directions? So yeah, it just opens the door for all types of new work.
Very, very cool. Last couple questions here before I let you go. You mentioned the monument there, Papahanaumokuakea, right? The big National Marine Monument. You're part of you're like an affiliate researcher, I think, with NOAA. Yeah, what's going on up there in a nutshell? How are those islands doing? Now that, you know, especially now they have the protection and a lot more, I think, scientific attention and so forth.
Yeah, it's just an amazing place. You know, it's such a special area. I mean, to have anywhere in the world that's remote and protected in that sense, where it's untouched, is just incredible. And so what it really is just a natural laboratory like I've never seen before. You know, we can go up there, and we're in the same archipelago. But the differences you see in fish, for instance, the predator biomass is insane because nobody's fishing. So you jump in, and instead of seeing a bunch of little fish that are the last to survive, that haven't been picked off, you're seeing the big fish that all that biomass should be supporting. So you've got sharks and jacks. It's so special and so fortunate to work in a place where you see what it should look like, right?
How often did you get to get there?
So I usually go up once a year on a specific expedition that's controlled and run by that monument program. So the monument has its own sort of division in NOAA that is specifically addressed, science and conservation and cultural practitioner in that area. And I've worked a lot with like Dr. Randy Kosaki. I wouldn't have been going up there if it wasn't for him. He kind of believed in the work that I was doing and thought it was necessary. And so I've worked in a partnership between the university and the agency and basically brought the science approach I was describing, looking at coral health and 3D reef structure, and we've just basically integrated it into everything they're doing up there.
Awesome.
And yeah, it's been fantastic, because we've captured disease events, we've had grounding events where a buoy runs off and hits the reef, and we can measure the exact impact and how it changes things. So yeah, it's just given us a better chance to study those systems, which are hard because that island, part of people forget the Hawaiian Island archipelago goes all the way up there, right?
Right. Is it like 1,800, 1,200 miles or some crazy
it's like
distance?
I think it's like going from the Mississippi River all the way to the Oregon coast. It's just huge. And that's why it takes us a month on a ship just to get all the way up there and back. And the other cool thing is, just for understanding corals, it's like going through time in a way, because I'm here on the Big Island. I've got reefs that are now a month old since the lava stopped, right?
Yeah.
Brand new substrate. I go up to Cure and I'm walking on reefs that's like 30 million years old.
Wow.
So you can actually go through the time of this archipelago from day one to the point that it's passing the Darwin point, right? It's disappearing. And
that's crazy.
Yeah, it is. It really is. And that's why I'm always like trying to get the word out about it. And so people realize like how special Hawaii is. There's very few places in the world where you have an archipelago smack in the middle of an ocean basin that has active to the end of an island's life.
Right.
And if we don't take the advantage to study that, it's a lost opportunity, in my opinion.
Yeah, yeah. To wrap it up, I noticed when I was reading your bio a little bit about you've done a lot of outreach, especially look like talking to school groups and so forth. So I just wondered what that's like for you, to be able to talk to students and young people about coral reefs in the ocean.
Yeah, I love it. Part of it is that I wasn't all into one spectrum and making sure that you're actively trying to train the next generation, then you're not building up a system that lets the planet get better and improve. We need to do that as scientists.
Yeah. Well, I totally appreciate that, and I value everything you said today. Really educational for me. Amazing stuff. And when I get back out there to visit, I'll look you up.
Definitely come out, man. I'd love to show you some of the spots. That'd be super fun.
Yeah, it sounds good. But hey, John, thank you so much.
Yeah, my absolute pleasure. Yeah, thanks for having me.
You're in the water loop. Water loop, water loop, water loop.